Welcome to the Graph Client tutorial. My name is Mel, and in this video you will learn how to integrate the graph queries directly into your React application using the Graph Client as a tool to generate GraphQL queries in JavaScript. You will be able to create queries for different subgraphs and even set subscription-like queries called live queries for real-time data stream into your application. This is a great starting point for using the graph and leveraging the API approach to obtaining on-chain data into your app. Our final application will look like this. On the ENS domain query tab, we will be able to query many domains, individual domain by their domain name, and also a filtering query to obtain domains based on their subdomain count. So as you can see, we can query many domains here, and if we click on any of the displayed ENS domain names, such as Vitalics, it will send us to the Etherscan page for the address or the ENS domain. In this case, we're showing that you can leverage the subgraphs API endpoints to obtain related data to the subgraph, such as the ENS subgraph, and how it aggregates us both the labels, names, such as vitalik.eth, with their address. Now, on the swaps live query, we will obtain a live stream of Uniswap's hosted service subgraph. We will be refreshing the data every 5 seconds, keeping in mind that Ethereum's blocks take 12 seconds to be settled or mined, if I'm not mistaken. As you can see, and I'm going to show you on this console log, sometimes we get the same data back, but we do get data back from the subgraph every 5 seconds, and whenever we get a new block information, the value is updated in our table. I have also included the resources for the graphs repository here, where you can explore several examples that the graph has provided. You can use your some popular clients other than the graphs client, such as Apollo or Oracle. Check for live queries or autopagination features, and also popular frameworks such as Next.js or even in Node, in a Node server. So let's see how does the graph work in a very high level overview. So I'm going to go to the documentation. I'm going to show you this diagram. The regular flow of a dApp, or a decentralized application, which is integrated with the graph, is as follows. A user interacts with a dApp, which adds data to Ethereum or any Ethereum virtual machine compatible blockchain through a transaction into a smart contract. This smart contract emits one or more events while processing the transaction. A graph node, which one can think of as a server, continually scans Ethereum for new blocks and the data for your subgraph they may contain. This graph node finds the Ethereum events that you defined in your subgraph and basically creates and updates the data entities in its store using this mapping or WebAssembly module, if I'm not mistaken. Of course, it's a little more technical than this, but as I said, this is a high-level overview. And finally, the graph node exposes an API, so any decentralized application can query the graph node for data indexed from the blockchain using these GraphQL endpoints. Then the dApp displays this data in a rich UI for end users, which they use to issue new transactions on Ethereum and just the cycle repeats. Now let's go ahead and with the coding and show you how you can start to integrate the graph into your application. Okay, so to start this tutorial, we will go ahead into the project repository for this tutorial and clone the repository using either this link or the SSH, which is not available right now as I'm not signed in. I have already done that on my local machine, and you also have to switch into the tutorial start branch. If you want to start from scratch, well, not from scratch, but from a basic template that has already loaded the components. And let's go ahead and explore these components or the file structure. So we have our source folder where we will be working mainly. This is a Vite project for with React. You can just clone the repository and install, and we will see very fast how everything works out of the box. And so we have our app.jsx file, which, as explained before, has these components. So we have the tab switcher, and inside the app.js file we have the navbar, each one element, the tabs container, and it has two main components. The ENS component, which is the one shown here, includes the ENS form as well as the ENS list display, and the swaps component, which will contain the table for the Uniswap data. Okay, so once we have cloned the project and switched to the tutorial/start branch, we can go ahead and install the dependencies. Just run npm install, and we wait for dependencies to be installed, and then we can start our development server. So what you should see now is in localhost 5173 is as follows. A shell of the components without any functionality. So if you click in any of these buttons, you won't get any data, and you are also not executing the live query, and we can start from here. So what we need to do first, after getting everything set up for the development, we need to install the Graph client package, which is created by the Graph protocol. So let's go ahead and install it. Run npm install. This is a dev dependency, so we should set the save dev flag, and if I'm not mistaken, it's Graph protocol /client-CLI. And once we install this, we need to create a configuration file in a root folder. This configuration file will be used by the Graph client to generate the GraphQL endpoints in JavaScript, so we can query the subgraphs that we will define, the queries that we will define inside our React application. So I'll come back once this finishes installing. Okay, it has finished installing, and we need to create this configuration file called GraphClient.trc. It's a YAML file. I have already taken the liberty to create it inside my project. As you can see, we defined the sources. For this tutorial, we will be using the ENS subgraph as well as the Uniswap version 2 subgraph. And let me show you how you can search for subgraphs in the graph. So you go here to products, and you can go to the hosted service, which are you can think of as free to use. And these are the ones that we will be using for this tutorial, the ENS subgraph and the Uniswap version 2 subgraph. And inside of here, you have this information where you can copy the API endpoint for both of them, Uniswap and the ENS one. And also you have this explorer where you can play around different queries, and it actually generates it for you. So you can just copy and paste the queries that you want to use into the defined files that you wish. What we did here is create a GraphQL folder inside our source folder. And yeah, this is important before hitting there. So we define our sources. We will be defining a plugin for the live queries, which is called polling live, and we set a default interval of 5,000 milliseconds or 5 seconds. And finally, we let the configuration file know where we want to access our GraphQL queries definitions, and this will be inside our source folder. and inside a folder called GraphQL, and any file with the .graphql extension will be read by the Graph client, and it will generate us the required JavaScript code so we can start querying into our React application. So for the definition of the queries, as you can see, these are queries that you can obtain, like I said, from the Explorer. So we will have one query for getting many domains, one query for get domain by label name. We will be passing two variables, a label name and a name. And the last ENS query will be get domain by subdomain account, where we will be passing two variables as well required, which will be minimum number of domains, which we will be using greater than or equal, and maximum number of domains, same, inclusive, less than or equal to the max integer value. Now for the Uniswap queries, we will be defining just one query, and as you can see, we have a very important directive here is called, which is the add live directive. This will indicate our graph client that we want this query to be set as live query, and we will get a different definition for this query into JavaScript, and I will show you what's the difference in a moment. Okay, so now that we have created the configuration file for the graph client as well as our queries, we need to add two scripts to our package.json file, so we can use, as you can see, graph client package to create our JavaScript code, and also to serve this graphql, which is a similar explorer to this one inside your local host, so you can also use the queries that you defined and start searching for data. This is all included in the documentation, and I will link also the proper pages where you can find this information. It's on the docs, so you shouldn't have any issue. And also, as you can see here, our dev dependency for the client CLI is already installed and ready to go. Okay, so we need to run this script so we can get our files. So let's go ahead to our terminal. I'm going to clear out this part, and I'm going to run npm run build-client. And what you will see is that what this client does for us is just generate us all the code inside a special folder, which is this one. Now you are free to examine this folder and get more insight of what is happening here. But for the purposes of this video, we're just going to go ahead and start coding our frontend. So now that we have our queries already to use in JavaScript, we'll head first to the ENS component, which is stored under components, and open it here. As you can see, we already have a lot of code ready to go for our integration with the graph. We have this state variable that is used to store the domains that we will be querying. These three variables are all related to the inputs, where we will be entering, well, the user will be entering information, and it's just handling the state of the inputs, a very normal and common flow in React. And finally, just a state variable for handling the loading state, just to provide a better UX to our users. I know that's redundant, but that's what we're going to do. We're also going to define three different functions, which are the ones that are going to be executed we'll be executing our queries. It's going to be one for get many domains, one for get domains by label name, and one for get domains by subdomain count. So let's go ahead and import the generated code from the graph client. Let's see. So we have to set the import statement, and we're going to point it to our created folder, graph client folder and look for the index page or index.js. And here, if you remember, for the GraphQL queries on ENS, we have one called get many domains, get domain by label name, and get domain by subdomain count. Let's import them, and as you can see, we already have all these methods and variables ready to go, which is amazing. Honestly, it saves you so much time, and you can just search for the required documents that contain the queries in JavaScript for the queries that we defined. Let's see, label by label name, get domain by label name. We need to use the document. There we go, the document, and also what was the other one? Get domain by subdomain count. Okay, and now that we have this, we will assign the functions to individual buttons within a form. As you can see, this is a form element where we are storing, we are placing our buttons and our inputs. So these three functions will all share the same pattern. Okay. So what we will do first is just prevent default behavior to avoid a page reload upon clicking the button. Let's delete here, and we will also go ahead and set is loading to true, since we are loading data from the API. Then we will go ahead and execute. Oh, I'm sorry, I missed that method that is created by the graph client, which is called execute. This method is the one that's going to be, as its name says, the executing the different queries. We need to pass this document as arguments, and let's go ahead and show how we can do that. So let's go execute. Now we have to pass in this case is get many domains document, and this is the first argument, and here is in case you need to pass, let's see, some variables. But for this query, as you can remember, we are not sending any variables. Where we are sending variables is in these other two queries. So for this one, we don't have to place anything inside this object, and we can just execute the. This is an async function, so it's a promise that needs to be executed, and it returns us a result, which we then can go ahead and place inside our set domains state function, which will change our domain's variable state, or state variable, sorry. And the structure for this is as follows: domains. Okay, so let's also, after it finishes, let's set our loading to false. Of course, here we can set more error handling better with a .catch. Now let's start our server. A .catch block. But for this tutorial, we're just going to. Okay. Let's see. Yeah, I was missing the document. Let's see, it's get domains by. What was the name of it? Get domain. Okay, yeah, it's a typo, so it needs to be get domain by subdomain count document. There we go. Okay, and now our application should be running. And while these ones we haven't hooked them up, but this one is already running. And there we go. We already have this information. I'm going to go very quickly into what is happening here for this list container. If the data is loading, we show the loader. As you can see, it's the graphs logo spinning around. And whenever the data finishes loading or is not loading, and we also have some elements inside our domain variable. That's why we ask for domain length longer than 0 or larger than 0. we show this unordered list element, which contains our domains elements here. we cycle through the array with the map method, and for every domain we get the domain ID and the owner's ID, and this is how we go through all the data that was returned by the GraphQL API or the Subgraphs API, and we show the domain name and a link to the Etherscan for the address. So we already have the first one. Let's go ahead and also, and I actually can just copy and paste because, like I said, the pattern is repeated. So for this one, it's very similar. We're just going to use a different document, which is the get domain by label name document. And in here, we have to just add the variables. So for label name, we need a refresher. It's label name and name. And why is this? Is because the label name is just in the, like it says, the name without the .eth extension, you could say, or domain. And you can place subdomains with different label names. So we also have to do the check for the name, which is the same string we will be using, the same string actually, just adding .eth to it, and you will see how. So first, the label name, we will just use the label name value that is stored inside here, which is derived from this input for the ENS label name. And for the name, which will go here, second argument, we are going to do a little string interpolation. I forget the name right now. So we're going to set the variable label name here, and we're just going to add the .eth extension here. So it should be good to go, and set domains, it's going to be the same, and also set is loading false. So let's save this and look for Vitalik's address. There we go, it's working. And here we have it, and as you can see, he has a lot of ether. And lastly, let's hook up the subdomain or the query by subdomain count. And this is going to be even easier because we're going to repeat this one and copy it. And we're just going to change the document, which we have already imported here. And we are also going to change the variables. So like I said, if we need a refresher, you can go to your query document and check the arguments that you defined. So it's a min and max. And the only thing we need to do here, since remember that JavaScript or not JavaScript, HTML inputs, even if you set their type to number, they save the value as a string. So we need to do a little parsing here to make sure that we don't get an error for parsing, or not for parsing, but just not sending the correct variable type, because as you can see here, we're expecting an int, which is a number in GraphQL. So let's go ahead and first let's set, like I said, also our inputs for min and max are already hooked up here in these state variables for minimum subdomains and maximum subdomains, or min max. And let's go ahead and just first set them here, and max subdomains. And here's the important part. We need to wrap this into the parseInt method. This is a native method, if I'm not mistaken, by JavaScript, so you shouldn't have any issue to just find it. Okay, and there we go. And everything stays the same. Like I said, it's a repeated pattern. And now let's test our last query for ENS. Let's go for our harder number, between 11 and 13. This query takes a little longer because you are adding two different filtering functions, and it also has to evaluate, numbers. But as you can see here, we have a different set of numbers than if you only query any domain. And as you can see, everything's working perfect. This is cool. So now we're going to go ahead and hook up the swaps live query using the Uniswap subgraph. So I'm going to close these files, and now let's go ahead and see what is the implementation for the swaps component, which is the table that contains. Well, let's first see from the app.jsx. So as you can see, we've done this ENS component part, everything's working here. And now whenever a user selects the DEX query or the swaps live query, we will show the swaps component. We will pass it down this loading state here, and also this swaps state variable, which will contain the data that is obtained from the live query. That's why we are passing it from the parent component to this child component as a prop. Inside the swaps component, I'm also declaring the props that we're expecting and some default values in case something is accidentally deleted. And it's just showing once again, if it's loading, let's show the loader, and if not, we can show a table with the information. It's the same pattern for the list. We have the swaps array, which contains the arrays, which will contain the array of our swap data, swap elements, and we can display them as follows. The ID for every element, table row element, the table data for the pair 1, the symbol, we're only use the symbol, but you can also access the name or even a lot of more data. Same for token 1. The swap amount for this particular swap in USD, and we're using a parse float to fixed because it I think it returns a string, and also the date or the timestamp we're obtaining here. This is a method to getting the date in a readable format for humans instead of the number that is provided by the Ethereum blockchain or any EVM blockchain, EVM compatible blockchain. So what we need to do is work on this subscribe live query function, which will be executed whenever our user clicks on this button, swaps live query. And this button here, as you can see, we're going to configure it that so it runs whenever this DEX query argument is passed into our function. So first, let's go ahead and hook this up. So just a very quick console log, triggering subscribe live query function. And what we are going to do here for connecting this execution here in our show component, we are going to go ahead and just make a quick evaluation. If our component is equal to DEX query, we will do this, await subscribe live query. So whenever our user clicks on the second button of the tab container, which is the swaps live query button, which is this one, we will trigger, since we're passing the DEX query string, we will trigger this this function, and we will start receiving the data. So right now we should just only console log it. I need to save this. Okay, there we go, and there we go. Trigger and subscribe live query function. Now let's work on the function properly. So similar as before, first we need to import the document and the method that we will be using to execute this document's query. And this is a different method than before. So let's just first define this path to the generated folder where we have all our JavaScript code for GraphQL queries. And this query is named get many swaps. We can return to our, I missed that. Let me define. Okay, I already gone around this, but as you can see, the name of the query is get many swaps. and we don't have to pass any arguments to it. It will return us order by timestamp, the first 15 elements. You can change this, of course, and we also are setting the order direction to descendant. We have the ID, the amount in USD of the swap, and the pairs, as well as the timestamp. Okay, so we have already our document, which was generated from that Uniswap queries file. And now, instead of using the execute method, we will be using the subscribe method. Like I said, this is a subscription-like method, but it's defined as live queries by the Graph team. So let's go ahead and code the subscribe, use the subscribe method. In a similar fashion to our execute method, we're going to pass our document where our queries are and the arguments. In this case, again, we have no arguments for this query, so we pass an empty object. We then, since it's also a promise, we're receiving a result object. The difference is that this result object actually has some methods inside it. And what we're going to be doing here is using this next method, which is the one that actually is going to bring us the information. We will execute it, and now we will define a res or response object, and we're going to check for if the response is actually not null, and also if it contains a value. This is the way I found it to be used. I wasn't able to find a much more clear implementation, and this works for getting the stream of data. If you find a better way to do it, please let me know, because I'm very interested about this. And I'm just going to put here querying according to interval, which is 5 seconds. Just to get it there. Or you know what? We can actually just console log something much more useful. Let's see. Let's use some variables. So first, we're going to say last registered swap value. Let's use the money part, which is easier to track than timestamps or pairs, because sometimes a lot of pairs are repeated. And we're going to need to parse float this. The structure is kind of nested, but this is how we're able to get it. We also need to put it to fixed 2, just to make sure that we have just 2 decimal points or 2 decimal numbers, and then we're going to save. Oh, this is, we have to get outside of the yikes. There we go. And as we have already here the state variable function, and we're going to save the data into the state variable swaps. Okay, now the tricky part, if we save this and run it, it's actually not going to run as a live query. We get the information once, but we don't get any more information. So what we need to do here is, and this is the fun part where I looked on how to implement this, is we're going to implement a little recursion. If we console log the res.value, here we see that we obtain an isLive property inside that res.value object, and we will be using this isLive property to trigger our recursion. I don't know if that's a proper way to say it. English is not my native language, but that's how I hope you understand what I'm trying to say, and if not, we can check it right now with the code. So I'm going to do an evaluation for this res.value.isLive, and if it is live, I'm going to set a timeout here, And we will trigger once again our subscribe live query function, and we will also do it inside the 5,000 milliseconds. And else, just to be safe, we are going to use another of these results object obtained here by the subscribe method, first call, and this one will finish it. And just an extra layer of safety, let's put a catch block here, and I'm not going to handle this error, just going to console log it in case there's an error. And if I'm not mistaken, we have already hooked the swaps part here, and on the bottom it's already should execute. So let's save and let's refresh our application, and let's click swaps live query, and there we go, we get the first query, and we are also triggering once again the subscribe live query function. And we still have not mined the new block here, so it should be soon that we get a new block with new values, like so. And there we go, we have our live query functioning, and our application is complete. So there you have it. Let's see, what did we do here? We learned how to integrate the Graph client into our React frontend. This tutorial should help you as a starting point to integrate the Graph subgraphs into your project and displaying on-chain data to your users, even in real-time data using live queries with an API approach. I hope this tutorial helps you become more proficient when developing Web3 applications. If you like the tutorial, you can show your appreciation by sharing it with your friends and coworkers. Thank you very much for your time. It was a little long, and I hope you made it to the end. You can always visit the tutorial repo. You can just clone it from the main branch and get it running, and you can explore the code there and see how you can start querying the graph. Once again, thank you very much for your time. I hope you enjoyed this small tutorial. I would love to have any feedback. Let me know what you think. You liked it, you disliked it. If you have any questions or any doubts, let me know. And I hope you have a great day. Thanks.